First of all, thank you everyone for coming along. Today we're going to talk about providing SData feeds from within Sage products. I'm Craig Pearson. I'm the Principal Business Analyst based in Newcastle in the UK, and I have with me Darren Cockram, one of the senior developers behind SData. He's also based here in Newcastle. I was going to start by just giving a brief overview of what SData actually is for the benefit of everybody who may be coming to this subject new. SData itself is based on RESTful web services. Now, I'm not going to go into that subject in any detail. There's a lot of material on the internet which explains the principles of REST and web services, and I'd recommend you go to that. The way I always describe RESTful web services is that everything within our applications becomes a resource addressable using a URL, and that's an example of a URL that we all use every day, via web browsers. Basically, you can connect to a server, you reference SData, and then you describe the resource that you would like. And Sage applications would then respond to those URLs. In response to the URL, you get some data, and that data is transferred via Atom feeds. And Atom is a public standard. It's based on RSS, which is really simple syndication, and it's the kind of format used in feed reading tools. But it is all based on XML, a very, very simple structure. What SData does is it takes Atom and it extends it to provide things that Sage require, such as user interface extensions, such as the ability to page information, and also to control what you want returned in the payload. And the payload is the data that is returned with the resource as part of the URL request. All of this is based on secure HTTP, so data can be exchanged between a client and a provider very securely, and it's all using the web. So this is really nothing that Sage has invented. We're just leveraging standards that are already out there. HTTP gives us not only the ability to retrieve and read data using the HTTP GET operation, but you can also post, put, and delete data via URLs. Posting is creating data, putting is updating data, and deleting is deleting. SData is quite a comprehensive specification, and it does cover a lot of other subject areas, such as concurrency, the concurrency of posting data, security, how data can be batched up, discoverability, so how you can discover the web services a particular Sage application supports, and also the query syntax that you can use to perform quite complex queries using URLs. The standard itself is available on the web at sdata.sage.com, and there's some good materials on there. There's some demo materials as well as the specification itself. And Sage has licensed the SData spec to be open source, so anybody in the world can take the specification and use it to write provider or consumer type functionality. What is used in SData is common data schemas, and these are schemas for data models based on XSD, which is the XML schema definition. And this involves data that is shared across Sage applications. And this is important in SData because it means consumers can receive standard information from Sage applications. Quite a leap forward for Sage, who has grown from a legacy of having lots of different data models and lots of different data structures. Most people think about SData from the consumer side of things. Basically, what I'm sharing with you there is a set of sample SData feed providers. These are all endpoints that are Sage applications that have implemented SData. If I was to click onto any one of those URLs and provide credentials, it would retrieve data from many different applications. So the first one retrieves data from Accounts 50, which is a UK product. The second one is Sage 1000, also a UK product, but more of an enterprise level system. We have Sales Logics, we have Northwind, which is a test environment. We have Murano, which is the Logic class product in Spain. And we also have Office Line from Germany. Now, what these URLs have in common is that they all support SData in terms of the URL syntax, but they also support a common data model. The term trading account is the generic name for customers and suppliers. If I was to click onto any one of those feeds, I would retrieve trading account information in a consistent structure. The data structure I received from Sage 50 or from Sage 1000 from Office Line would be the same. Now that is quite important because it allows consumers to consume or use those feeds, and they only need to build the logic to work with one data structure. Now the feeds themselves can be consumed by a web browser, and when I send you this presentation after the session, you can click on any one of those URLs and actually see the data retrieved in a web browser. But quite importantly, it can be consumed by another Sage or even a non-Sage application. Most, if not all, of these products have implemented SData to provide data to our CRM product range. Sage CRM, Sales Logics, and Act are all designed now to work with ERP or accounting system providers that support the common data model and support SData. But the onward benefit of them supporting CRM is that the same feeds can be used in many other applications. They can even be used in other devices. So we have a range of mobile applications around Sage that also use SData. And connected services is a key part of our strategy moving forward, which involves retrieving data using SData from on-premise applications and providing value-added services via the web to our customers. In the UK alone, we're seeing a number of connected services that are reusing the implementation of SData from Accounts 50 and Sage 1000 to deliver connected services. There is no increased burden on the R&D team because they've already implemented the data that is required. They've already implemented SData. We are now exploiting that implementation. So what does it take to be a provider? Well, that's the purpose of today's session, and I'll just step through some initial building blocks of what it takes to be an SData provider. This is the best way of visualizing what is required. There is a comprehensive document behind this available via the open website, and there's a reference to it there. But in principle, what we have is sort of the foundations of the provider capability, and that is the SData specification itself, the standards such as HTTP, XSD, and Atom that it uses, and an implementation of SData called the SData framework. Now this is what's going to be used today to highlight how you write a provider, and this framework is based on C#. Okay. Then becomes, on top of that comes the data specifics. So you have the common data models that we use, as well as the functional or contract requirements of what your product management team or what your marketing team want from SData. Taking the common data model, you would then write what we call an instance schema. And the instance schema is an application-specific version of the common schema, and I'll talk a little bit about that later. But ultimately, what you're looking to deliver is an SData adapter that you bundle and package with your products that responds to SData web service requests. To take the standards and the SData specification, industry standards, I'm sure everybody is aware of what HTTP can handle in terms of the methods for handling data. CRUD is your create, read, update, delete model. XSD is simply the XML schema definition, which controls the structure of the data that is exchanged. And Atom is the actual language, the XML language used for the web feeds themselves. The SData spec then clarifies things like the URL syntax, how you would ask for data, how you would ask for service operations. It also controls the metadata that applications must support, which advertises the rules for how you process data. So SData says there is metadata that allows you to describe the services that you offer. You know, can you read pieces of data? Do you support synchronization? You know, there's a whole section of the SData specification which revolves around SData metadata. Okay, and there is also the payload control side of the specification. So how you want the atom feeds to be structured. If you're delivering a large, volume of information, the atom feeds can get quite large. So SData gives you a mechanism for breaking those down via paging. Payload control can control how feeds are paged. Okay. Looking at it from a data point of view, we have these common data schemas, which are based on analysis of a large number of Sage applications, and they cover a number of functional domains, such as accounting, CRM, human resource, payroll, fixed assets, and project management. They're all defined in XSD, which is the XML schema definition language, and there is a large library of definitions published on GitHub, which are available for download and for use. The good thing about these is that you can take a piece of data from one of those domains, such as a general ledger record from accounting, and that will be the same structure as used by other development teams across Sage. We are collaborating to that extent. A key thing when writing a provider, though, is to develop your instance schema, and that is your application-specific version of the common data schema. The common data schemas are quite large, quite comprehensive. They need to be to support all the different types of Sage application there is. What you define in your instance schema is what your application supports. So if you're implementing an instance schema for Sage 200, for example, you can use metadata to declare in your instance schema what you support. Pieces of data, for example, certain types of records, may simply be unsupported, that may not be available in your product. You would simply mark them in your instance schema as unsupported. Similarly, you may say for a particular piece of data, you support the read operation. So you would declare in your schema that you can get that piece of data, but you may not allow update operations. You would set can put to be false in that regard. Things like whether the data is searchable, whether it's optimal for your application to respond to search queries on particular records. You could say this can be searched or this can't be searched. You can even provide labels. Because the common data schemas are all in English, you can provide local language labeling. So what the users of SData see is the name of the resource or the name of the data in local language. Now, metadata also applies to the fields within the records. So you can specify a particular field can be used to sort data, can also be used to filter data, is a unique key for your application, is a collection of data, again is simply unsupported. There may be a large number of fields in the common schemas that are not supported by your application, and you would simply mark them as such. And there is also the ability to label at a field level. This is sort of meshing the common data model with your own database schema and advertising through metadata rules what you support. Moving on to what it takes in terms of a contract. Contracts in SData define the relationship that exists between the provider application and its consumers. They lay some ground rules as to what is supported and what isn't, and that allows applications to be built which use corresponding functionality. It means that you don't get somebody developing an HR consumer against an application that simply doesn't support HR data. This is more at the functional level, and there are various ways of implementing SData contracts. These are examples of what have happened so far within Sage. There is the contract where you say, right, I will provide everything I have in my database, because you never know who now or in the future may want to consume it. That is the approach taken by OfficeLine in Germany. They basically SData enabled their full data model. Virtually every piece of data that is in the common data schemas If there is a corresponding entry in Office Line, it will be available. So they've provided access to a lot of their data via SData feeds. A number of applications have narrowed down the number of entities they support based on a pre-existing contract. And I mentioned the most important one that's been implemented to date. That's the accounting and CRM contract. CRM knows what to ask for from accounting products because of the rules in this contract. And each of the accounting system or ERP system providers has implemented a provider just to support those rules. Importantly, a number of products are writing providers to support very specific use cases. Now that may be integration between applications or between applications and the web, or to deliver particular connected services. So for example, an online payment service, all that really needs from an application via SData feeds is the data necessary to effect a payment. So that typically is just invoice details, customer details, and very little more. It is suitable within SData to write a provider just to support that context. And I suppose the key message I'm trying to get across there is that contracts are very much up to you. There have been one or two centrally defined contracts, such as accounting and CRM, but in the main it will be up to product management, business analysis, your R&D leadership to say, right, we have these particular customer use cases that we want to satisfy. SData is the technology to do that, and to support that use case, these are the pieces of data that we need to support. And it is on that basis that you would typically write your SData provider. Finally, there's the more technical aspects of actually writing the code to write the SData provider. I mentioned SData frameworks. These are typically developer frameworks for working with SData. They handle or take care of many common tasks, such as serialization and deserialization of feeds, routing of requests to the appropriate point, handling authentication, and even doing the hosting side of things. They allow developers to focus on the functionality, the business domain that they're trying to deliver, rather than needing to totally understand the SData protocol. Now, the protocol itself is very comprehensive. The SData frameworks abstract developers from that level of detail and allow developers just to work with classes that they are familiar with, that represent the operations they want, such as delivering feeds, supporting SData operations, that kind of thing. Finally, the SData adapter is what is shipped installed with the product. It provides a bridge between application data and RESTful requests. And that's another key point to get across. Your SData adapter can be a sort of a secondary piece of functionality within your application, separate from your database, with a separate development pedigree. You can keep the two parts separate, and that's quite important because it allows both the SData adapter and the core application to evolve at their own pace. We're going to write one now, and I'm going to hand over at this point to Darren Cochran, our lead developer with SData, who's going to write an SData adapter using an SData framework called the SIF, which is the Sage Integration Framework. Okay, and I'll hand over to Darren at that point.